All right, so we are back in geometry. Today's date is Wednesday, September 25th, 2019, 9/25/19. Make sure your name and date are on the paper. Who wants to read our objective with a quiet raised hand? I don't see any cards out there. Where are the cards? Oh, yes, I see Jenny has her card. Yeah, thanks. There it is. I get your card. Andres gave you the 50 XP. You guys are on it. It's self-managing now. All right, let's start with something easy. When did we learn the area of a rectangle? Did we learn that in kindergarten or was that first grade? It was some long time ago. I think it is first grade because in first grade they say, well, how do you do 2 times 3? Well, you make a rectangle. You make a rectangle that has 3 blocks and then it has a height of 2 and you do 3 times 2 and you just count them up and it's 6. It's multiplication. That's the basis idea of what multiplication is. So in order to find the area, this area of the rectangle, can I give it a quiet raised hand? Tell me my formula if I have a base and a height. Is there a quiet raised hand that has a card in it, Jose?
Area equals base times height.
There it is. Base times height. Everyone write it down. B times H. It's the most simple formula that we have. It's nice and easy. And again, I'm using B as a, it doesn't have to be B. It could have been X and Y. But I'm using B because that usually means base. And I'm using H because that usually means height. And height is an interesting word here. I'm always trying to stay as technical as possible in geometry because we want to be precise. Precision is standard 4. Where is it? I attend to precision. I guess it's standard 6. We want to be precise in mathematics. So when I say height, height means that I come up at a right angle. If I had something that looked like this, that came off at an angle, and I said that this length was some other length, I'll call it x, it's not x times b because this is no longer at a right angle. I can only say it's a height if I have a right angle. Are we all okay with that? All right.
Wait, Mr. Shindo, so in the precision thing,
Yes.
that the logo is from NBA 2K. It's an archetype. The sharpshooting archetype gunner. That's the sharpshooting archetype. The purple precision one from up there.
I have no idea.
I saw that last year.
It's the same one.
It is, right?
Let's talk about a triangle. We had a triangle in our warm-up. The area of a triangle is always what of the area of a rectangle? Always, always. I'm looking for a fraction here. The area of a triangle is always what the area of a rectangle? Is it a third? Is it a fourth? Is it a half? Is it an eighth? What is this thing? Is there anyone that has a card? Josie, I think you have your card still. It is a half. Everyone write it down. It's always half the area of a rectangle. And you might be thinking, well, yeah, I know that. I've already learned that. But I always like asking the question, why? If I come back up here to my rectangle, let's go ahead and don't write this down first because this is too easy. I'll do a hard one with you guys. Don't write this down. What happens if I split the rectangle directly through these diagonals? If I did that, then I would have 2 triangles, and these 2 triangles are exactly the same. The triangle in the bottom left is equal to the triangle, or is congruent to the triangle in the top right. They are the same shape, just flipped and then matched together. If these 2 triangles are the exact same thing, if I take the entire area and divide it by 2, then I get the area of one of these. Does that sit okay with us? 2 triangles, they're both the same, so if I divide this whole area by 2, I get the area of one of these triangles. Hopefully you're okay with that. If it's making you feel uncomfortable, then now's the time to ask questions. Andres?
So would you have to divide by 2 because there's 2 triangles?
Exactly. If I could somehow divide this into 3 triangles, I could divide by 3 and get the area of each of those triangles. Yeah, good question. So, should we do a new procedure? If you guys ask like really good questions, can I assign XP to it?
Yes.
Because I really like that question. So I think that you deserve...
Sindel, what if that question I asked last year? That was a really good
That was
question.
last
It
year.
related to math.
This is the worry that I have. Then people will argue, well, what is a good question, what isn't a good question?
Wait, so do I get XP?
I'll think about it. So from now on, we're still doing the same on the same old rule where we don't know if you get XP. I'll think about if good questions deserve XP. But what happens if I do something harder? This one you are going to write down. Let's choose a point somewhere around here. So it's still a triangle. Let's go ahead and make our lines to it. So it goes from the bottom corner, bottom left corner, and the bottom right corner to that point. Well, I don't see two equal triangles anymore. So why is this, I'm going to call this bottom triangle down here, why is this bottom triangle right here, why is that half of the area? Can anyone see why? Why is this triangle now half the area of the rectangle? I told you that a triangle is half the area of the rectangle, but you need to tell me why. Why is this triangle half? Does anyone see it? This one might require you to get up to the whiteboard. Yeah, Gunnar.
I might know. Possibly.
Go for it.
If we move this way, it's half.
Okay, so you're kind of going off of the warm-up where the warm-up said, if I move this triangle left and right, then I can eventually move it to the exact same point, maybe make a right angle right here, and it's exactly half. So that's a good idea, but we haven't proved that we can even move this thing yet.
You're moving it.
We talked about it in the warm-up, but we haven't proved it. So is there anyone else that has an idea that you could somehow add, it's called an auxiliary line, we haven't learned it yet, but can I add some sort of extra line here that makes it clear that I'm still dividing this in half? Does anyone see it? Fernando Hood? Anyone see an auxiliary line? I'll give it to you guys. And it's just based on time. I wish we had more time. If I had like an hour to just play with this, it would be a fun problem. Let's go ahead and add a line right through that point. Let's stay easy so far. Do we all agree that this rectangle right here and this rectangle right here both add to the same area as the total rectangle? No. No? Why not? Just joking. Okay. This rectangle and this rectangle add to the whole rectangle. That seems pretty straightforward. Well, look at these two triangles. What do you notice about them? Shout them out. They're equal. They're congruent is the geometry word. Their areas are equal, but these triangles are congruent. What about these two triangles?
Not congruent.
Oh, yeah.
Not equivalent.
They are congruent again. Which means if I want to find this area, this triangle right here has half the area of this right-hand side, and this triangle right here has half the area of the left-hand side. Well, if I'm adding half and half, it's half of the total as well.
Wow.
And you can do this for a bunch of other types of triangles as well. So, can someone give me the formula for the area of a triangle? If I know that the area was base times height and I'm always taking half of it, can someone tell me what my new formula is? Something that you should have memorized from all the way back in 8th grade, I believe. You don't have your card anymore, do you?
But,
Okay, fine. You can participate. Give me your card, though.
okay. So,
Area is equal to.
B times H divided by 2.
There it is. B times H divided by 2. Everyone write it down. There is your formula for a triangle. By the way, this is equivalent to a separate formula that is saying the same thing, which is 1/2 base times height. You can say it either way. Both are the same thing. It's 1/2 of a rectangle. So there's the picture way of thinking about it, splitting it in half, and then there's the formula way of doing it, which is just 1/2 B times H, base times height. Let's move on to some harder things. Here's an example that you might see in Khan Academy. It looks strange. I gave you too much information. Try to solve this. You can either use a formula, you can somehow make a square out of it, somehow find the area of that triangle.
Stop believing this. Bro, stretching.
I will give you guys some hints to start us off. I need to find a base and a height because base and a height are the two things that are used in our formula, base and height. And I know that the height should make a right angle to the base. Can anyone see what the base and the height are of this triangle? What are the two numbers that I'm going to be using? That's the hint I'll leave you with. So go ahead and work it out on your own. All right, so we're back. Is there a quiet raised hand that can walk me through what I'm doing for this problem? Is there anyone that has their card still? No one has their card? Fernando, yeah.
Hey, you had.
Wait, do I
Walk me through the problem, yeah.
Okay, so you're gonna circle 4 and 2
Why 4 and 2?
because those numbers make a right angle.
Those numbers make a right angle. So far, so good.
Right. And then you're gonna multiply 4 times 2 and then divide it by 2.
All right, so we're doing 4 and 2. I guess the base was 2, but I can write it as 4 times 2. It would be even better to say 2 times 4, even though it's the same thing. And then you said divide by 2 at the very end?
Yes.
And what do you get when you multiply that all out?
So you're gonna get 8, or you're gonna get 4. The answer.
4. And then because we are talking about area, if these had centimeters, it would be centimeters squared. If it had meters, it would be meters squared. Because I don't have units, I'm going to say units squared. And I can pronounce this different ways. I can say that this is unit squared or square units. It doesn't matter how I pronounce it. Both methods are correct. So you can say that this is called square units or units squared. We're talking about area. Whenever we have area, it should have something squared for our units. All right, let's try parallelogram. So, obviously this looks hard to find its area, but I will tell you this. You only need a base and a height and then somehow play with those numbers and you can get an answer. So I'm going to follow the instructions here. I'm going to cut off the end of a parallelogram and move the piece over. So here we go. Everyone write it down. I'm going to, and it doesn't matter which piece you cut off, I'm just going to arbitrarily, randomly say, I'm going to cut off the right side. The thing that does matter is it has to be from this vertice. This vertice making a right angle and coming straight up.
That doesn't make sense. That's not a right angle.
Right here.
Oh.
This angle, as Gunnar pointed out, that has to be a right angle. This angle right here is definitely not a right angle. But this angle here is a right angle. I'm going to cut that part off so I have this piece by itself. Think about a piece of paper. I just cut that piece off. I am going to move this piece over in this empty spot. If I do that, it should fill in perfectly. This is obviously demonstrated much better with some paper if I had it. That did not work. Come on. If I hold shift, it should stay close enough.
So what's your opinion of back talking?
I don't like it.
Yeah.
It does make you a wittier person, though, I guess. All right, so if you can visualize in your mind's eye now, you can even hide it with your hand. Obviously, I can't do that because it's a projector. The X is right there. But hide it with your hand. That doesn't exist anymore. It ends right here, and it comes over there. What shape did we just make? If we cut off the end of a parallelogram and move the piece over, we make a
Rectangle.
We should always assume it's a quiet raised hand, but you guys got it. It is a rectangle. No one gets XP.
No class procedure?
Nope, because class procedure is a quiet raised hand. You made a rectangle. Well, what is the area of the rectangle? Is there a quiet raised hand that can tell me what the area of this parallelogram is? You wrote it down up above it, a rectangle. It's nice and easy. It's one of the easiest formulas you ever have. There's not a single quiet raised hand that can tell me. Oh, Monse, yeah. There it is, B times H. Which is kind of cool, right? You would think it would be like maybe 4/5 of B times H. No, it's exactly B times H. That's it.
Mr. Sano, since I'm the game warden, can I make up rules for...
No. All right, so I want you guys to not only have this formula down, what's more important than the formula is knowing this. Knowing how to transform a parallelogram into something easy like a rectangle. Fernando, can you put that away? Let's do example number 2. This is something that you might see on Khan Academy. Again, I'm always choosing the hardest possible example on Khan Academy to see if you can get it. If you can get these hardest possible examples like example 1, example 2, or example 3, then I think you're ready to go. I think that those are the most tricky types of questions. So, they gave you too much information. That's why it's tricky. What is the area of that parallelogram? I'll give you guys about 30 seconds to multiply to figure out which two numbers you're going to be using. By the way, your numbers are going to be base times height, so you're finding, again, two lengths that make a right angle with each other. So you're going to be circling those two numbers. So you're circling the numbers, you're multiplying them out, you're getting an answer, and then you're going to check with the person to the left and the right of you. Check with your neighbors. What are your neighbors getting? Are they making a mistake? Maybe they need some help. Maybe you can get some XP. All right, so it looks like about 90% of you have stopped writing, which means I assume you all found the answer. Is there a quiet raised hand that wants to tell me how to do this? Let's even start easier. You don't even have to tell me how to do it. Just a quiet raised hand. What were the two numbers that you chose? Is there anyone that has a card still? Anyone has a card? Julian, it looks like he's going to do his card. Are you going to go for it, Julian?
7 and 5.
7 and 5. Why'd you choose 7 and 5?
They make a right angle.
There it is. That is the correct answer. You do not use 8. 8 has this weird slant to it. It's not a 90-degree angle right here.
Wow.
Thank you, Julian. And then can someone just tell me what the area of the parallelogram is then? With correct units, with a quiet raised hand. Yes, Andres, with your quiet raised hand.
So it's 35 square units.
There it is.
Or, I mean, not square units.
Yeah, you could say square units.
Oh, yeah.
No, that's wrong.
But wouldn't you have
35 square units.
But wouldn't you have to then divide it by 2?
You don't have to divide it by 2 because it's exactly a rectangle. A rectangle is base times height.
Oh,
This
yeah.
formula is base times height. You multiplied 7 times 5 and you got 35. So I'm going to go over here and box 35 units squared. Let's go to the back. We're on the trapezoid. The trapezoid is notoriously hard because it's not a simple formula. These formulas up here were nice. B times H, B times H, B times H. One of them had a half in it, and that's the hardest thing. This guy is a little bit hairy. Here we go. He's a little bit difficult. So let's assume, let's hide this red rectangle. Put your hand over it. Everyone put your hand on it. Let's hide this red rectangle. I'm only looking at the blue rectangle. That's my starting shape. Notice that you have this length right here and this length right here, which are different lengths. So I'm going to call this one B1, base 1, and this one B2 for base 2.
Go get it.
Oh, yeah, go for it. Base 1 and base 2, they both make a right angle with the height. The height has to make a right angle. I'm repeating this over and over again. If the height makes a right angle to B1 and B2, then you're on the right track. So what I'm going to do, I'm going to follow the instructions. Make a duplicate of the trapezoid. Whoop, I made a clone of them. It's the red ones. I need to flip it upside down and put it to the right side. So this is a clone now of the blue trapezoid. The problem is, we only want to find the area of the blue trapezoid, which means if I find the area of all of the shape, what do I need to do with the quiet raised hand at the very end? If I have found 2 trapezoids, but I only want to find the area of 1, at the very end, I'm going to do what, Cohen? There it is. Everyone remember this. At the very end, because I've duplicated this, I need to divide by 2. Nod your heads. We understand. Okay. Thank you, Cohen. Do you have your card in already? No. So, but what shape is this now? If I ignore this center line right here, this blue line in between the blue and red trapezoid, what shape do I have? Quiet raised hand. What is the name of that guy? We just studied him on the last side of the notes. What shape is this? Jose? Not quite. This whole shape that goes from here to here.
No problem.
What is that, Jose? It is a parallelogram. We have a parallelogram, and we know the formula of a parallelogram because, again, I'm going to do the same steps. The same steps were to do this. I make a cut right here. Go ahead and write it down with me. I'm making a cut right there that makes a 90-degree angle, and I'm going to cut this piece off, and I'm going to put that piece all the way over here. If I do that, then I get the following shape.
Wow.
Again, in your mind's eye, you have to do this. You have to kind of cover this right-hand side that we cut off with your hand, and it's right there. We have now made a really giant rectangle. But as Cohen said, that rectangle is going to be 2 times too big. Let's go ahead and do some math now. We need to find the length of the base. The base is now this whole length. This whole length of the base, the height didn't change. The height's still there. So, can someone tell me what the formula is for this newly created rectangle? Eventually we're going to divide by 2. We're not going to do that yet, though. I just want the area of this giant rectangle. Who can tell me what that is? It's going to be this entire base. I need to add these 2 together, and then I'm going to multiply by something else. Tell me what my formula is.
The formula.
Cohen, go again.
B1 plus B2 times H.
B1 plus, I'm going to do color-coded, plus B2, all of that times H. There it is. Everyone write it down. Cohen has figured out the formula for this entire giant red this entire rectangle that's the blue and the red trapezoid. This entire rectangle is base 1 plus base 2. This thing right here represents the base. This length right here, I just added them together. Then I multiply by height. Now's the time to ask questions. That's probably the most confusing step. No? No questions? Question?
Okay. So, wherever you find the vertex, you just draw a line above it, and then the leftover shape that you cut, you just put it on the other side.
Yeah, and because this line right here has the same slope as this line right here, they're parallel, they should match up perfectly. They also have the same height. Yeah, good. No. But keep trying. Okay, and then Cohen's final step is to divide everything by 2. So I'm going to divide everything by 2 because we have two times too many trapezoids. And there it is. There is the formula for a trapezoid. So more important than the formula is how to get it. If you can just recreate this image over and over again whenever you see a trapezoid, then you will automatically be able to get this. The formula comes from the pictures. If you can remember the pictures, the formula comes naturally. Another way to write this that you see in textbooks often is like this. B1 plus B2 divided by 2 times H. There's another way to write it, but you can have it whatever way you want. There's also a cool little thing here. It's kind of a little, another way to think about the problem. Whenever I have two numbers, let's say I had 1 and 3. If I want to find the average of 1 and 3, what do I have to do? Is there a quiet raised hand that can tell me how to find an average? If I have an average of 1 and 3, if I have a number 1 and 3, what is the average of 1 and 3? Sergio.
So you add them 4 and then divide by how many?
Exactly. So add them and then divide by 2. Look at what we're doing. Adding and dividing by 2. What you're doing here is you're taking the average of base 1 and base 2. This right here means the average of this length, and then multiply by height. Kind of cool. And what that really is saying is you're kind of moving these diagonals and slowly turning it into a rectangle. And because it's a rectangle, you just multiply by height. So another way to think about it. And I'm going to write this down too, because it's another way to remember it. As many times, or as many ways to remember it as possible. That'll help us. This is the average. Length. L-E-N-G-T-H. There we go. Of the bases. All right, we're almost out of here. I need you guys to use your formula, use your picture, somehow find the area of example number 3. Go for it. All right, who wants to find the area? One person walking through it. Gunnar, go for it.
Okay. A. First A. Okay, 8 times 4.
8 times.
8 times height. Teacher.
Okay. I'm with you so far.
I think that's minus each.
What next, Gunnar?
8 times 4 is 32. So, yeah, 32 squared. Wrong.
That would be true if I was dealing with this shape
Oh.
right here.
It's 26. No, it's 26.
Minus 5.
Can someone else try this one? You already participated, but you have participated less than other people that have their hands raised. So Fernando.
No. So it's 4 and 5. So it's 4 times 5.
No. Student error again, Mr. Sindel. Mr. Sindel.
So if you're ever confused, go back to the formula. What is the first thing that I'm doing right here?
You're going to
What's-
add the bases.
Okay, what are the bases?
8.
And?
5.
Okay, then what?
Fernando, let me do it.
Okay, and then you're going to multiply it by 4.
Okay, and then?
And then divide it by 2.
Okay, let's do that. What is 4 divided by 2? We can reduce that right now.
That's 2.
So it's going to be 2 times,
2 times 13,
which is?
which is 26.
And what is our final answer?
13. No, wait.
26.
26 units squared.
There it is.
I was here.
All right, so let's go back all the way to the objective. We always end this way. Fist of 5. How well can you do the objective and calculate the area of triangles, parallelograms, and trapezoids? I got a 3, a 4, a 4.5, a 4, I think, a 3, a 3, a 4, a 4, and a 4. All right. All right, you may begin on Khan Academy.